Okay, so in this problem we are asked to find, we are told that these members, they can support certain force. They can support 8 kilonewtons in tension and 6 kilonewtons in compression. And we're asked to find what is the maximum force P that you can have that this truss can support, or this joint here D can support. So let's use the method of joints, and let's start by drawing the free body diagrams of each joint. So let's start with joint D. And so joint D would have what? Would have the force P, of course, that has the force P, and then it's going to have a force coming from DC, force DC, and then it's going to have a force DE, and this is force DC. All right. So those are the three forces at joint D. So let's write the equations of equilibrium. So for the y-axis, we have F dc sine of 60 degrees minus P, that's equal to 0, right? So that is in the next one is for the x-axis, the forces for the x-axis, it's going to be F dE minus F dc cosine of 60 degrees, that's equal to 0. And then using these two equations, I can solve as a function of P, and then I'm going to get that F dc that is equal to 1.154 P, and that is in tension, and F dE that would be equal to 0.577 P, and that is in compression. So I have the two forces at D as a function of P. So now let's move on to this joint here, joint C. The free body diagram for joint C would be F dc here. Then I'm going to have F CE, and then finally I'm going to have FCB. So that is the free body diagram for this joint. And then we can solve, that is joint C, and then we can solve now. We can write that the y-axis, for the y-axis we get that FCE sine of 60 degrees minus FBA, sorry, F, not BA, so minus FDC, right? So FCE sine of 60 degrees minus FCD, right? Sine of 60 degrees, that is equal to 0. And then for the x-axis, I'm going to get that, here I'm going to have this force and this force, right? For the x-axis, I'm going to have the components of this force. So now this force here, the signs cancel, so I can actually go ahead and write FCE, which is equal to FCD, right? So I can write that already from this equation, and then when I write this, I'm going to have that this is 2 times FCD, right? And then that goes with the cosine of 60 degrees minus FCB, and that is equal to 0. And so and now here I can solve for FCB, and I get that that is 1.154, and that is as a P, and that is in tension. So I have done this guy and I have done this guy. So the next one that I should be trying would be this joint D. So let's draw the free body diagram for joint B. For joint B, we would have the force FCB, then we would have this FCE, and then we would have this FDC. And now I can go and solve here. This is supposed to be FDC. I can go and solve here. So let's do the Y component. So the Y component would be FBE sine of 60 degrees minus FBA sine of 60 degrees. That's equal to 0, and that tells me that FBE is equal to FBA. I have that done now, and now I can go ahead and do the next one, which is the x-axis. So for the x-axis, what I'm going to have is that then I'm going to have this guy here, right? For the x-axis, I'm going to have this guy here and the two components, but I already solved those, so I can write that this is FDC, right, minus 2 times FBE, because it's going to be the same, right? Cosine of 60 degrees, that's equal to 0. So then I can solve, and I can get that FBE is equal to 1.54 P. So finally, I can do the last join, and that join would be join E. So I'm going to do this join here. So let's do the free body diagram for join E. For join E, we would have a normal force. Then we would have a force coming here. So this is a normal force EI, right? Then we would have FEA, and then we would have here FDE, and then we would have this force coming here, FDE, and finally we would have this force coming here, and that is FCE. And then I can write that I don't need to solve, I don't need to do this guy. I'm also going to do this one here. And then I'm going to write the x-axis. That gives me FEA plus 1.154 P cosine theta 60 minus 1.154 P cosine of 60 degrees. That's equal to 0, and then from then I can solve FEA is equal to 0.577 P. So now I have all all that I need, right? So I can write that the maximum force ever is going to be this guy, and this is smaller here. And if I go back up here, yeah, so it's this guy here. So the maximum tension or compression that I'm going to have is this. So I can write that 1.1547 P, that is going to be actually the maximum either tension or compression. I'm going to set that to the maximum tension compression that you could have, which is 6 kilonewtons, and from there I get that P is equal to 5.2 kilonewtons. And that is the problem.